In this problem, we have a system of equations word problem. This is a easier question. Captain and Mark is selling pies for a school fundraiser. Customers can buy blueberry pies and lemon meringue pies. Captain sold 7 blueberry pies and 2 lemon meringue pies for a total of $49. Mark sold 7 blueberry pies and 7 lemon meringue pies for a total of $84. What is the cost? What is the cost of one berry blueberry pie and one lemon meringue pie? So the first thing you do is to set up a system of equation, which is basically two equations that work together. This is why they're called a system of equation. But you might be confused to how are you supposed to start this problem, or what are you supposed to know in order to set up your problem? Well, don't overthink this problem. So we are actually given two variables here. We have blueberry pies, okay, 7 blueberry pies and 11 meringue pies. So either one could work. So I'm gonna set x equals our blueberry pie, and y is gonna be our lemon meringue pies. Okay, so we just set up our variables. It doesn't matter if x is our meringue pies or y is our blueberry pie. It doesn't matter. Okay, now we are given that since for a system of equation, it has to be two variables that equals some sort of amount, so total amount. Since they gave us for Kaplan, she sold a total of $49 and Mark sold a total of $84. Since we already know the numbers, which is 7 blueberry pies and 7 lemon meringue pies for Mark. Okay, so we can set up our system of equation. We're starting with Captain first. So 7x plus, okay, it's plus because we have the total of 49. So we're adding the total of these pies, okay? So 2y equals 49, okay, our total right here. And for Mark, 7x plus 7y equals $84. Now the question says that what is the cost of one blueberry pie and one meringue pie? So we're basically solving for x and y because we don't know their values, so we label them as x and y for 7 and 2, but we don't know how much they cost. Okay, this number just basically tells us how many did Captain or Mark sold. Since they sold 7, Captain sold 2 while Mark sold 7. Okay, we only know how much they sold, but we don't know the cost of one pie. So that's basically why we are using this to solve the system of equations to solve this. Okay, so you can see it in this kind of form, or you can see it with a curly bracket right here. But I like to set up my equation like this and put a curly bracket. Just keep me know that there are system equations. You don't have to, but it is not necessary to. Well, the first thing you see is, do I use substitution or elimination? For this one, you have to use elimination, because for substitution, that could work too, but I'll basically stick with elimination since it's my favorite, but it doesn't matter which one you do. Okay. Well, the first thing I'm going to do is to multiply this bottom one by -1, okay, because I want to cancel out the x. So when we're doing this, we have to write our first equation now. Okay. Now for our new equation, we have to multiply everything inside of here with -1. Don't forget that. We're not just multiplying this left hand side, okay? We have to multiply the 84 on the right hand side. 7x times -1 is going to be -7x minus 7y equals -84. So when we have our new form in the second equation, we can just add them. Every time we do this, we have to add for elimination. Okay? So 7x plus -7x, they're going to cancel out eventually. Now 2y plus a -7y, that is basically thinking of 7 minus 2 is going to be 5. But since -7 is bigger, we have a negative, so -5y. Okay, for this one, we have 49 plus -84. We can think of this as 84 minus 49. Okay, so for this, 4 minus 9, we had to carry a 1, so 14 minus 9 is 5, so 7 minus 4 is going to be 3. So we have 35. So since negative 84 is bigger, this is going to be a negative 35. The next thing we would do is divide both sides by negative 5. We get y equals 7. Why? So we know that for one lemon meringue pies, it costs a total of $7. But now we need to find x. When you find a variable, we just plug it into the first or second. But I like to plug this into the first one, okay? It doesn't matter what you're going to do, so I'm going to plug into this one. So 7x plus 2 times 7. So this is just direct substitution, okay? Now, 2 times 7 is going to be 14, plus 14 equals 49. And then we had to solve for x to be minus 14 to both sides. 7x equals 35. Okay, we divide both sides by 7. The 7 cancel out. We get x equals 5. Okay. Okay, when you have your answers like this, it's best to write your answer like how much the blueberry pie costs and how much the lemon meringue pie costs. If you box like this, your teacher might mark you wrong because you're not sure what you're talking about, but some teachers will accept it. So for this, you have the right answer like one blueberry pie costs $5, while one lemon meringue pie costs $7. In order to make sure you've done the math correctly, you can check your work by plugging these values for x and y. So we're gonna plug it in for both, okay? 7 times 5 plus 2 times 7, does it equal 49? Let's do the math. 7 times 5 is 35. Plus, this is 14 because 2 times 7 is 14. Equals 49. 35 plus 14 is 49. Equals 49. Yep, that's true. It works for the first equation. And how about the second one? 7 times 5 plus 7 times 7 equals 84. So that's going to be 35 plus 49. It's going to give us equal 84. So 35 plus 49 is going to be 84 equals 84. Yep, both of those are correct. So this tells us that our answers for x and y are correct for this system of equation.